Welcome to one and all. I hope you guys are ready, for maths paper 2. Yay! I hear there's some excitement here in the middle. Or it might be the food talking, I don't know. Ladies and gentlemen, just first of all, is there any of you that have not received the packs, the papers, with the slides on it? Okay, I'm just want to ask, okay, sorry, let me just quickly see here. Okay, there we go. Okay, so, okay. I'm going to ask you guys just send it there to the back. Okay, if you haven't received, please put up your hand. It's coming there to the back. Please make sure you get one. Okay. Now, ladies and gentlemen, welcome to the last 2 hours of academics for the exam preparation school. I hope you are all awake. Kind of. I hope that you are ready for this. Those of you that are only joining us from today, hello, my name is Mr. VG, and I will be your chief tormentor for this session. And I absolutely love paper 2, okay? Because paper 2 contains the 4 sections that are arguably the most difficult sections, those 4 that I'm displaying right now on the board. But it is arguably the most difficult ones, but the ones where you can score the most marks. You're like, okay? Ladies and gents, as you look at all of that theory that is on the board or that's on the paper in front of you, as we said yesterday, look, it is at this moment of time going to be very difficult for you to make summaries of all the theory, all the knowledge you need. So what I would encourage you to do is, as you go through the list, have a look at different ones that you can actually see, I am not really good with it. So if you are, for instance, so we're adding this discussion here in the front, if trigonometry is not your strong suit, then I would start with trigonometry. For one reason, it is 50 marks in your paper. So that's about 33% of your paper 2 is going to be purely trigonometry. But I am going to flip this around to what I actually wanted to do last, I'm going to do first. Because I realized with the Afrikaans guys when I did it with them, to try and do Euclidean geometry after you've been busy for an hour and a half is not a good idea, okay? So what I'm going to do is I'm just going to dive into this. I'm going to ask you, on that pack of papers that you received, please go for me to the last paper, or the last question, which is that one there. Okay? In the diagram below, PL is a tangent to the circle LMNF. MF and LG are produced to meet at P. NF is produced to cut LP at G. Prove that triangle LNM is similar to triangle LGF. Prove that PF is a tangent to the circle. And if LG is equal to 2/3 of LP, use similar triangles to prove that LP squared is equal to 3PF. You have 10 minutes, ladies and gentlemen. Go for it. Gentlemen, I know that you might not be done at this moment of time, but just for the sake of not sitting here for another 5 hours, I know all of you would really like to, okay? You don't want to go and do fun stuff after this. You'd rather sit and do maths. I know that. Ladies and gentlemen, I want to go through this question, but please you will not see this question in your finals. Oh, so, okay. So what do I want to do? I want to go deeper. I want to get you to think in a specific way. Now, you remember when we started off yesterday, I said to you guys, what is your end goal? Do you guys still remember that question? Someone said the end goal was just passing matric. Okay, someone's end goal was, I want to get good marks at varsity. And then I want us to go much further than this. And I want to teach you guys the 3 basic problem-solving techniques you can use in maths and everywhere else in life. Okay, gentlemen, just look me in the eyes. Do not try and do this when you are married. Okay, these problem-solving techniques don't work when you're married, because my wife constantly looks at me and goes, I'm not a math problem, you can't solve all problems like that. But then I just say, but that's the only way I know how. So ladies and gentlemen, I want to tell you, in all my years of teaching, I've only come across 3 types of problem-solving techniques. Well, however you want to solve a problem, it is going to fall into one of these 3 or more than one of them, a combination of them. The first one you guys will know very well, although you've never heard of it before. The first one I like to call the gung-ho method. Okay, have any of you heard about the terminology called gung-ho? Okay, you have.
Yes.
What does it mean, sir?
It means to go direct without thinking about the consequences.
Okay, so to go directly into something, very descriptive something, without thinking about the consequences. 10 out of 10 for you. I love it. Do you know where the terminology comes from? It comes from the First World War. Especially gentlemen about your age, maybe a year older, 18, 19 years old, who would completely go off their mind, completely lose their mind because of war. So they would run into battle and kill anything and everything that comes in front of them, whether it is an enemy combatant or their own people, they don't care, they just shoot. They called it the gung-ho method. Unfortunately, that's how you guys do mathematics. And unfortunately, that's how most of you also handle problems in life. Unfortunately, that's the truth. And I'm going to share with you guys a simple reason why. Your age, and this is now, I'm not a biology teacher, but I've done quite a bit of research about this. There's a little part in the front part of your brain called the prefrontal cortex. At your age, it is not developed at all. It's only fully developed between the ages of 25, research now suggests 28. That is the part of your brain that deals with consequences. Okay? So that is the part that deals with, if I do this, then this is going to be the good or the bad that comes from it. Okay? I used to work in an all-boys school, which is a lot of fun, because you get a boy on crutches and you're like, what the hell did you do? And so I jumped off a roof. Why? No, my friend double dared me. Like, but didn't you have like a rugby match this weekend? Oh, sir, but this happened Friday. You're like, but didn't you think about what's coming? No, sir. He dared me. I couldn't resist the dare. I had to go for it. That's the bad side of the gung-ho method. The good side, that's why we need you guys in the world, is you guys are willing to stand up to make changes, no matter what the bad consequences could be. That's why I'm using it as an example. Someone like Greta Thunberg, some of you might know her. Okay, that girl that's about environmentalism and everything. She doesn't care who she irritates and pokes and completely wants to wipe her off the earth because she stands up for what she believes in. So is the gung-ho method bad? It's okay. It's only good, ladies and gents, for me in two situations. Number one, if it's an emergency. Let's say, champ, what's your name? Tato. Let's say your mate next to you all of a sudden starts choking. Are you now going to sit for 5 minutes and look at him and go, what's wrong? Are you all right? And quickly go and read a book about how to help him. Are you going to do that or not? No. You're going to use the gung-ho method. What is the problem? Do you have all the necessary knowledge to necessarily help him? No. So please, I'm warning you, be careful of just running into some things. We've heard, and it's been documented a lot of times, people come up to a car crash, they see people are injured, they just pull the people out, and the people they pull out are paralyzed for life. Because they don't have all the knowledge about how to secure the neck, etc., etc., etc. So sometimes the gung-ho method doesn't work. The second time it does work, really it works well, is if you've got no cooking clue what the hell to do. Okay? If you see that maths problem and you're like, I have got no cooking clue, let me just write down something and hope and pray for the best. Then this method works. Not to be advised. Then, ladies and gentlemen, we get to the second part, which is mining. Literally digging for information. Ladies, you love to mine. Oh, I've seen it happen often. We as men, we hate to mine. Let me explain what I mean. If my wife comes home to me and she's crying her eyes out, as a man, what's the first thing I want to do?
Ask what's wrong.
You ask what's wrong and then you try and solve the problem, am I right? Yeah. No. Am I right, ladies? I see a few of you are laughing. Okay, is that the right thing to do for me?
Sorry?
Is that the right thing for me to just try and solve the problems?
No. Yes, no.
Yeah. Yes, no. I promise you the answer is no. I've been married for 11 years. The answer is no. What is the right option? Mine. Oh, my love, what's wrong? Why are you crying? What happened? Can I help with something that happened? No, I just want to talk. Okay, let's talk. What, and by the end of the whole story, I've gotten all the information. As a man, I want to go, no, how can we help? And she walks away and she's like, thank you. It's all right now. And you kind of go, okay, I just solved all the world's problems, but I did not even get to a solution. Because just for interest's sake, gentlemen, if you want to know, take a tip from a guy who's been married for 11 years. Ladies solve problems through verbalization. Gents solve problems through doing things. That's why, gentlemen, if you are really angry, You are really irritated, something really bad happens. You go with your buds, you go and, shoot a game of pools, or you go on the cricket court, or the tennis court, or the basketball court, on the rugby field. Afterwards, all the world's problems are solved. And the ladies go, but you didn't talk about anything. No, but that's how we problem solve, is by doing things. And I always say God has a sense of humor. Putting someone who problem solves by talking and someone who problem solves by doing in relationships. It makes life very, very interesting. Not always the best, but yes. So let me quickly say, when you problem solve and you mine, you are not focused on the solution, you are focused on the information. Geometry. Hashtag just saying. Okay? Then, ladies and gents, before I go to the last one, the biggest problem with mining, just before we move on, is a terminology that is called analysis paralysis. Might not have heard about it, but it basically means you analyze the problem so much that you don't do anything to solve the problem. I'm going to use an example, and I hope it's not on YouTube. It's one of the biggest problems in politics in South Africa. We set up commissions and commissions and commissions, and they dive into all the problems, and they get paid a lot of money to dive into the problems. But by the end, when they've got all the information, the problems are still there. It's called analysis paralysis. So please be careful when you are doing paper 2, because paper 2 is a lot about mining, that you don't get analysis paralysis where you spend 15 minutes on just the information and you never actually get closer to where the answer is. Then we get to my favorite. This is the one that I coined a few years ago, the monkey behind the mountains. The monkey behind the mountains. Now, the monkey behind the mountains, ladies and gents, is where your focus is not the information but the solution. So your monkey is the solution. In other words, how do I get there? What do I really want to solve? The mountains are all the obstacles that stand in your way to get there. Now, this is a very, very worthwhile tool for you to start practicing in maths. Then when you're proficient with it in maths, start applying this to everyday life. Because this is one of the most valuable tools for a businessman or business lady. If you combine these two things, mining and the monkey behind the mountains, when you have your own business, that's a business plan. That's a business plan, just laid out very nicely. As engineers, this is where your money comes from. You start by getting what is the problem, what information is given, then you start going, but I want to solve this. So what do I want to solve? How can I get there? How can I get there? How can I get there? This is basic problem solving, and you can practice it in core maths. Okay? So what I'm going to do, ladies and gentlemen, is I want to take you through this specific question paper. This question for me was an absolute beaut. I think it came from the Ashton International College. If you ever find some of their papers, amazingly difficult papers. So nice challenge. But what I'm going to do is I'm going to ask you guys, I'm going to ask one of you to read the information for me, please. Who's willing to do that? Okay, who's willing to do that? Then it's not a trick question, guys. Just read through the information aloud for me. Yes.
In the diagram below, PL is a tangent to the circle LNF at L. NF and LG are produced to meet at P. NF is produced to cut LP at P. ML is parallel to MG.
Okay, and you've missed everything. Let me quickly. You missed everything. You read through everything and it's fine, but you missed everything. Because what you guys do, and please, if you want to quickly go on your question on the slides, go for me to the slide about Euclidean geometry. Okay, the slide about Euclidean geometry. I'm going to quickly see if I can get it up here. Okay. There we go. What are the first 2 points that I say? The first point says, start at the question. That's where a lot of you guys went, am I right? You guys read 12.1. Prove triangle LNM similar to triangle LGF. Okay, then you go, how do I do it? Am I right? I'm glad I heard a no from somewhere here. But there was a lot of you that I was looking at here going, okay? What is the second point? Not going through the information thoroughly. I'm not just saying read through it. Go through it thoroughly. In other words, mine. But here comes the bit of the negative. For you to mine proper, you have to know your theory. So let me show you how I mine. And I hope that some of you might be inspired to do this as well. So let's try again. Okay, please read for me and I'll tell you when to stop.
We'll start with the questions.
Start with the information. We're going to mine now.
In the diagram below, PL is a tangent to the circle.
Stop. PL is a tangent. Okay, let's stop. What do I know about tangents? Before I go any further, what do I know? Okay, you already skipped to the end. I've got theorem 7, 8, and 9. I like to go through it systematically. Then I know I'm not going to skip anything. First of all, I know with a tangent, theorem 7 says that the radius is perpendicular to the tangent. Chord. Do I have a radius? Nope. Theorem 7 is out the window. Theorem 8. 2 tangents from the same point are equal. Do I have 2 tangents? Theorem 8 is out the window. Theorem 9. Okay, I'm drawing it a bit weird here. Tan chord. Do I have a tan chord? Yes. So I can use my fingers and I can get that L1 is N2 as well as M2. But now look at the secret, sir. Before I move on, I write for myself, those angles are because of theorem 9. So I know when I go back that I know where to go back to. Okay? Do I have anything more about tangents? No. I've exhausted all the information. Now I need to move on. MF and LG are produced. That to meet at P. So in other words, they are straight lines. Nothing earth-shattering there, so I'm not going to worry about it. NF is produced to cut LP at G, another straight line. Then we get to a very important one. ML is parallel to NG. So what must I think of when I think about parallel lines? I must think about fun, because maths is so much fun. Okay? No sarcasm involved. What else must I think of? Say again? Yes, that is the end. What else must I think of, grade 12s? Ooh. You don't know where. Yes.
When you're doing properties of quadratic
I like it. I like it. You must think about the quadrilaterals as well, like trapeziums, parallelograms, rectangles. Not used often, but I can think about it. More important, what about theorem 1 of matric work? Ooh, if I've got parallel lines, then the sides are divided into proportion. So in other words, if I've got parallel lines, I have sides that are actually in proportion to one another. Do not forget about it. To answer 12.3, you actually have to use this. Hashtag just saying. Okay? But let's run through the F, the U, the N. I've got parallel lines. So the first F is there. M2 and F4. That is an F. Then L1, 2, and 3 is equal to G2. That's also an F. With alternate angles, I have that M2 is F1. Also, L3 is N2. Also, now I think that is pretty much it that I've got there. Okay? Everyone all right with that? Please get that I'm not just randomly plucking theorems out of the air, I'm systematically going through them. Now when I look at the actual question, am I ready to move on to the question?
Yes.
No. I was waiting for that. Did you look at cyclic quadrilaterals? Oh, do not forget to look at cyclic quads, because that's the one set of theorems we won't tell you it's there. So you have to look for it. So where's my cyclic quad? Okay, so let me quickly get my cyclic quad there. There I've got my one bow tie. Okay? Which means that angle and that angle is the same. It also means that angle L3 and F1 is the same. There's so many of them, if I write all of them in, I'm going to have way too much information on my sketch. Do I have something else about cyclic quads I must look at? Ooh. So again, let's go at it systematically. I need my bow ties. I need my exterior angles. So if I've got an exterior angle, it means that F3 is equal to M1 and 2 together. And that is an exterior angle. Everyone is all right with that? Okay, now ladies and gentlemen, I've done the mining now. I've used up all the information that I can. Now I only go over to the monkey behind the mountains. So what is my monkey in question 12.1? I need to prove two triangles similar. Now I ask myself, so there's my monkey, similarity. How do I do it? That's the mountains. Which angles must I prove equal to one another to get this right? So the question is, triangle LNM, let me do it in pink here, LNM must be similar to triangle LGF. So first of all, L1 must be, okay, L1 must be equal to L3. Secondly, F3, well, let's go systematically. N1 must be equal to G1. And lastly, I need angle M must be equal to F3. If I can have those pairs equal, then the triangles will be, but don't I have that already? L1 is equal to N2, but N2 is equal to L3. So I already have proven that. Do I have angle M equal to F3? I've already proven that. So automatically my third pair of angles must also be, oh sir, I already have that. There's my 5 marks. Ladies and gents, I've done this kind of geometry for many years now. If you are going to do geometry the way I'm showing you now, 70 to 80% of geometry, the marks are in your pocket, guaranteed. Guaranteed. Let's quickly look at question 12.2. Prove that PF is a tangent to circle LGF at F. Okay? Please, I'm going to say it very nicely. Don't be an idiot and tell me, but sir, LGF doesn't lie in a circle, so it cannot be a tangent. Please, you might say, sir, kids won't say that. Yes, kids do. I've marked many matric papers. What does the question actually mean? I know you guys don't think about that, but what does the question actually mean? There's a circle somewhere. You are so very descriptive here. There's a circle somewhere. It means if I had to theoretically draw a circle around LGF, that the line PF would be a tangent to that circle. That's what we are asking you. You've got 2 options. What are my 2 options to prove a line a tangent? Say again? Converse of tan chord, right? Okay, I'm just using the fancy English words here. So in other words, if I've got a triangle like that, if I can prove that angle and that angle the same, then it will be a tangent. So please, let me give you a tip. Before you answer this question, actually write out for the examiner what you need to prove. So how do I start this question? I actually go to the examiner, I say RTP. What do I need to prove? Which angles must I prove equal to one another? I must try and prove F4 equal to which one, sir? L1. I need to prove F4 equal to L1. And can I give you guys a sneaky little insight into matric marking? If you write this, you've got 1 mark. Even though you haven't answered the question, but you've showed the examiner you know what to do, so they'll give you 1 mark, even if you don't answer the question. But now, sir, what do I know about F4? It's equal to Okay, no, it's not yet. That's what I want to prove. It's equal to M2. So F4 is equal to M2. What do I know about M2? It's equal to, oh, they have proven the sum. 4 marks in your pocket.
Wait, F2 is equal to?
Our F4 is equal to M2 because it's corresponding angles. Remember, we have this here. And I have very much earlier have that M2 is equal to L1 because it's tan chord. And therefore I have proven it. Yes. Fantastic. Did you use F1? You used F2 equal to? Oh, lovely. I love that. I didn't even see it. Well done. So what she said, what is awesome, is she went and used that F2 is N1. Am I right? Because it's angles in same segment. Let's not use bow tie for the examiner. Okay? But in question 12.1, what did I prove N1 to be equal to? It's equal to G1. So then you have proven exactly. Well done. Yes, sir. I love it. Okay. Which way did you have? And this is our last way we're going to use for today. I love it. Fantastic. Fantastic. So he said that L1 and L3 is the same. Remember, we proved it. And L3 is F1. And F1 is F4. Perfect. Ladies and gentlemen, this is the beauty behind mathematics. You've got to find a way that works for you. Don't try and do everything my way, although my way is awesome. Okay? But you have to find a way that works for you. Now let's quickly look at question 12.3. Quickly look at the mark allocation. 7 marks. What does that tell me? Except for run to the heels. What does it tell me? There's 2 things it must tell you at this moment of time. Number 1, there is no restriction on how many lines you can write to answer this question. What do I mean by that? Look, if I'm answering a 3-mark question, the moment I start writing more than 5 lines, I start doubting myself. But a 7-mark question, free for all, half a page, I don't know. We don't know how the examiner is going to mark it, so it could be that long or that short, we don't know. So it's basically as long as you want to. What else do we know? If I see 7 marks, I know there's going to be a lot of in-between steps to try and answer this. So there's not going to be a straightforward way to do this. So I want to share with you some of my dirty old school tricks. Okay? The moment I see a square, okay, the moment I see a square, ladies and gents, okay, and I'm going to write it out again. So the question is LP squared equal to 3PF squared. The first thing I think of is what? What is the first thing that you guys think of when you see a square? Say again? I love it. I don't go there first, but I love it. Okay, she's saying there might be two sides that are somewhere equal. That's going one side that is occurring twice and it ends up a square. Can I tell you where my mind goes first? Pythagoras. If I see a square, the first thing I think of is Pythagoras. But if I look at the sum, are there any 90 degrees? So I'm not going to go towards Pythagoras, simply because there are no 90 degrees. So what I'm going to tell you is I want you to learn to break this sum up into small little bitty pieces. So I'm going to manipulate the living daylights out of this sum. And I love it. Because what we need to do, ladies and gentlemen, is we need to somehow get triangles involved in this. So how do I do it? Let me show you how I manipulate. First of all, I'm going to divide both sides by LP. Then I'm going to divide both sides by PF. Okay? Who can quickly tell me why do I do that? I get rid of the squares. Someone said it. So that one divides away with one of those. That one divides with one of those. So I'm left with LP equal to 3PF. And this is over PF. And that is over LP. Okay, remember, please, grade 12s, you don't write this for the examiner. This is your own side notes. Okay, this is your own side notes. Because let me share with you do you want to know why I do this, huh? Because usually the denominators and the numerators will give me the triangles I work with. Remember, when working with similarity, it always leads towards ratios. And the ratios leads me towards, again, similarity. So if I look at the sum, I can first of all find triangle. Let me just copy this. Just to make life a little bit easier. Okay. Okay, there we go. What is the top triangle? Let's quickly look there. Okay. Just going to move this aside there. There we go. Okay. Is there a triangle PFL? Look at the denominators. Is there a triangle PFL? Oh, there's one triangle I need to work with, because it's in the denominators. But now the numerator is a bit of an issue, because LPF, although it is a triangle, that letter 3 is throwing me off completely. So now I need to kind of see, isn't there some magic I can do? Ladies and gentlemen, why did we give you LG, life's good, is 2/3 of LP. Doesn't that look familiar? Don't we have parallel lines? Which means this is 2x, that is 1x, and that is 3x. Oh my hat. But can I tell you what's the beautiful thing now? So if I look at this, 3 times by PF is actually MP. So which are my triangles that I actually need to work with? Triangle LPM and triangle L, or not LP, but triangle LPF. This is not in the right order, I'm just saying. But these are the two triangles that I'm actually going to need to prove similar, so that I can have my ratios, so that I can get my numerators the same, so that I can end up with what they are asking me. Oh my goodness. There's a reason why this is 7 marks. But what I wanted to share with you is not something that is unique to this sum. It's something that I wanted to share with you, and you can know and go and try the sum yourself. Okay? Is whenever they ask you, it's usually like the last question in an exam. Prove that this thing is equal to that plus that plus that. Please get that that proving is going to involve similarity. It can involve proportions. So you have to somehow figure out which triangles must I prove similar, so that I can set up the right ratios. It's just not easy stuff. There's a reason why this is the last question in the exam. But ladies and gentlemen, do not just leave it open. Please don't just leave it open. Okay, everyone all right with this? So I'm challenging you, go and finish this one off. Okay?